Alright, now we're going to take a look at the answers to the Turtle Egg Rescue index card assessment that you did in class the other day. You are able to improve your score by making corrections up to a 9. So if you got less than a 9, please watch this video. And then you can add a post-it note to your current answers. So don't erase anything on your current answers, but just add a little post-it note with the correct or improved answer that you'd want to use. The first question was pretty straightforward. It said, what would the final temperature be in each reaction? And you were just supposed to fill in the table. So here, if we know the starting temperature is 23 degrees in every case, all we have to do is look at how much the temperature changed. And so in option 1, it went -1 degree Celsius, so we go from 23 to 22. In option 2, it dropped from 23 to 17 because they recorded a decrease of 6 degrees Celsius. And in option 3, we started at 23 degrees and went up to 25. The next question might be one of the trickiest on this little assessment, so don't worry if you missed it. Question 2 says, explain what would happen to the temperature if you added only chemical A to water. And I asked how you reached this conclusion. Assume that chemical A will react with water on its own. I only showed option 1 and option 2 because those are the places where we're going to be able to get our data to answer this question. You'll notice in this case, chemical B is 1/4 of a teaspoon both times. That's kind of serving like a control in this experiment. When I add more of chemical A, I have half a teaspoon here, and I double the amount to 1 teaspoon here, I can see what effect A has on the reaction. I know that A is causing the change again because B is the same in both cases. When you have 1/2 teaspoon of chemical A, the temperature goes down by 1 degree Celsius. When I double the amount of chemical A, you'll notice that I get a 6 degree drop. So again, because chemical B is the same, I know that increasing chemical A makes the reaction get colder or lose more thermal energy. So if I add chemical A to water on its own, I know the temperature would decrease. I know this because in both option 1 and option 2, the amount of chemical B stays the same. Only the amount of chemical A is increased. When the amount of chemical A is increased, the temperature drops more than when there is less chemical A in the reaction. Go ahead and fix your answer. If you did not have this one correct and you want to adjust it, you can pause the video and add that in. The next question says, turtle eggs need to remain at approximately 24 to 28 degrees Celsius for them to remain safe. Would any of these design options work? Most of you did identify that option 3 works because it's at 25 degrees, which is right in the middle of the range. Again, here's a written out answer to that if you would like to take a moment and adjust that. If you didn't explain why, you may have lost a point on that. For the fourth question, you've been asked to create option 4, a new reaction that would work for the turtle eggs. So to fit the reaction in the portable incubator, you can't use any more than 1 teaspoon of any chemical. Some of you missed that part of the prompt. And you can only choose to use 1 chemical if you would like to. Remember, you guys, that chemical A causes the temperature to drop and chemical B causes it to rise. The closest that we have to look at is option 3. Option 3 gets it to 25 degrees, which works for the incubator, but we might want to try to get it just a little bit warmer so that we're not at that bottom edge of the safety range for the turtle eggs. So in this option, chemical A, they added 1 teaspoon, and we know that makes it colder, and 1 teaspoon of B, and we know that makes it warmer. That did get us into the range, so we're pretty comfortable using this amount of chemical B, but in this case, we may want to change the amount of chemical A. Chemical A makes it colder, so if I use less of it, my reaction's going to end up a little bit hotter. So answers could vary a little bit, but if you used about between 1/2 and 3/4 teaspoon of A, about 1 teaspoon of B. I accepted any answers where you used more of chemical B than chemical A. These answers here, the predicted change and the predicted final temperature, these are just approximate. You have no way of really knowing how to calculate that without doing the actual reaction. So I accepted any answers that showed an increase above that 25 degrees. So here's a written out answer to question 5. You can go ahead and take a look at that, pause the video if you need to. All right, question 6 was reading a graph. It said temperatures between 24 degrees and 28 degrees are safe for turtles. Here with the blue line, I have shown the bottom cutoff. So anything below this line is not safe for turtles. Anything above the red line, 28 degrees, is not safe for turtles. So the green line here represents the temperature in degrees Celsius. So at the 10-minute time point, this shows that my temperature is 21 degrees. This is not safe for turtles because it's not warm enough. It's not until about 15 minutes here where the temperature hits 24 degrees. All along here, between 15 and 20, between 20 and 30, between 30 and 40, up until about 43 or 44 minutes, the temperature is between my red line, the upper limit, and my blue line, the lower limit. So that would be the area of the graph that I shade in. If you shaded your graph in a little bit differently, but you had the same time frame, that would be perfect, and I accepted that answer as well.